Okay, so some notes on Dalton. He was actually credited as the first person to have real physical evidence that particles existed, and namely the atom. And so he's one of the few scientists I'm going to go over. I'm not going to bother to explain how he figured everything out, just rather what he figured out. So this can be found in your textbook as well if you look up Dalton. So you can get a slightly different view of that. So Dalton really figured out, he lived in these experiments were done in the late 1700s, early 1800s. And so one of the things he said is that atoms are the tiniest possible thing. The atom is the smallest thing there is, and that it can't be dividable. It's undividable or indivisible. He came up with a pretty simple model of the atom. He just considered it a sphere. Okay. And then he also said if you have a whole bunch of the same type of atom, so if you took your pencil, for example, the end of your pencil is made of carbon. It used to be made of lead, but today they're made of carbon. If you took your pencil and could get down to a single atom, that's what we would call an atom. And if you ever looked at the periodic table of elements, you might wonder, well, what's the difference between an atom and an element? And it's actually relatively simple. If you took a whole bunch of carbon atoms, for example, okay, and you started piling them together in a pile, eventually you'd have enough of them that we would just call it the element carbon. So if you had one atom, you'd call it the atom carbon. But if you had a whole bunch of them, you'd call it the element carbon. Okay, but notice it has to be the same type of atom. So let me give you another example. Let's say you had, how about the element hydrogen? Okay, well, one of those we'd call an atom. But if you had thousands or millions of hydrogen all in one area, we would then call it an element. Now here's an example of what I'm talking about. So here I have a hydrogen atom represented as a small circle, and here I have a bunch of small little dots together. Those would all be considered the element hydrogen. Could do the same thing with oxygen, and have a whole bunch of them. We have the element oxygen. Well, you may wonder where we get all the diversity of life. So, not of life, of all the things around us. So, for example, there's really about 120 or so elements, and even way fewer that are pretty common on the Earth. I believe somewhere around 20 or 30 real common elements. So how do we get all the things that there are in the universe? And really all we're doing is we are taking two or more of those elements, and they can join and they make something entirely new that we call a compound. And that compound does not act like the original two or more elements that made it. It acts like a whole new thing. What I tell kids in class is if you took like a BB and a marble and you put those two together, instead of having a BB and a marble, you'd have like an elephant. It makes something totally different, which is one of the bizarre things about chemistry. So in my example I gave in class, so well, if we had the element hydrogen and the element oxygen, and you bring those together, instead of hydrogen, which is a gas that's explosive, and instead of oxygen, which is also a gas, you bring those two things together and you make H2O, or water, which is a new compound. It doesn't act anything like the original two things that made it. It acts entirely different. So that is a summary of what Dalton figured out.